We're doing 2-4 notes on writing linear functions. And again, this is a review, but we want to make sure that we have all of our facts straight and we can do this in different forms. So to write a linear equation given the slope of a line and a point, we're going to use something called point-slope formula. This is one of the ones that you're not as familiar with, but we want to be using it. So point-slope formula is y minus y1 equals m times x minus x1. This comes directly from your slope formula. If I wanted to solve this for m, I would divide both sides by x minus x1, and I'd have the formula for slope, the change in y over the change in x. But we use this as point-slope formula, and you're going to need the slope, which is one ordered pair, and you're going to need the 1 point, just like they said in the directions. So here is my 1 point. This is my x1, and this is my y1, and m is my slope. So I have what I need. And what we're going to do is we're going to use point-slope formula. Okay, so I'm going to use point-slope, then solve for y to get y equals mx plus b. And what is y equals mx plus b? What's the name of that? Like, if I say y equals mx plus b, what's the name of that? You can say it. Slope-intercept form, isn't it? Slope-intercept. Okay, so we're going to use point-slope, and then we're going to solve for y. So here I go. I'm going to plug in what I know. It's always going to be a y minus the y value equals m, which is -4, and then parentheses, and then x minus a -1, and that's where we have to be careful, that extra negative sign. So it's your general y minus the y value you're given, the slope we have, times the quantity x minus the x value we're given. And then we were going to clean this up. So if you were doing Delta Math or a test and it said, give the equation in point-slope form, you are done. You don't actually distribute anything. This is point-slope form, but you do have to clean up your negative signs. Okay, so you would write this as just x plus 1. Now that I have that, so again, I'm going to say it one more time. This would be your cleaned up point-slope form. So if you're asked for point-slope form, that is it. Okay, so that is point-slope form. And now we are going to put it in slope-intercept form. So we are going to distribute y minus 7 equals -4x minus 4. And to solve for y, I would simply add 7, and I get y equals -4x plus 3. So just to note, this right here is point-slope form, and this is slope-intercept. You're going to have to be able to negotiate between the two for directions like to use this or to answer it like this. Okay with that? So same idea. I'm giving you a point and a slope, and we're using point-slope form. So go ahead and set that one up, and then we'll see if we agree. Be careful with your x's and y's. So I put in my y, I put in minus the -6 for my x, my slope is 2/3. I clean up that minus negative. So if you were asked for point-slope form in the simplest form, this is it. That's point-slope form, clean up that extra negative sign. Then we are going to take a minute and we are going to distribute and solve for y. And if you need a calculator, you can use it, but I think a lot of you can catch, we could cross cancel. That's 6/1, the 3 and the 6 reduce, and you'd be left with a +4. The last step would be to get that 5 out of there to get y by itself. Y equals 2/3 x plus 9. And this is slope-intercept form. So we have 3 forms. We have slope-intercept, y equals mx plus b. We have point-slope, y minus y1 equals m times x minus x1. And just to put it back in your brains, you remember what standard form was? We went over this the other day. We just did it yesterday. It is where x and y are on the same side, but it looks different. It's ax plus by equals c. Those are the three forms of a linear equation. Standard form, point slope form, and the one you're most familiar with, which is slope intercept. Okay, so make sure you know each form and what it is so you can use it. Okay, now we're going to change it up. If you look at examples 3 and 4, I give you 2 points. Up here, I gave you a point and a slope. Here, I'm only giving you points. So we're going to have to do a little more work. Your slope formula is given using 2 points. So we have the first point and the second point. These little 1s and 2s aren't powers. They're subscripts to say first point, second point. And your slope formula is always the change in y. So y2 minus y1 over x2 minus x1. And then I'm going to rewrite your point slope formula, which is y minus y1 equals m times x minus x1. So you could use y equals mx plus b to write your equation of a line, but you can also use point slope. So you have to pay attention to directions. And if the directions just tell you to write the equation, you could use whatever method you're comfortable with. We want to practice point slope because this is going to help you in different math classes. So it's something that we're laying that foundation for. Okay, to use point slope, I need 1 point and the slope. I have 2 points. What am I missing? The slope. So what do I have to do first? The slope. Okay, so it does not matter which point you call x1, y1, but I'm just going to be consistent. This is going to be my first point, and this is going to be my second point. And I know you all know how to do slope, but I want to make sure you slow your brains down. It is always the change in y over the change in x. So if I start with this y value, 7 minus, I'm going to go to this y value in 1, and then I'm going to come back. You have to start with that same point, and my x is negative 3, but it's minus a negative 6. So I need you to watch that minus a negative. Okay, so let's clean it up. In the top, I get positive 6. In the bottom, I get positive 3. Final slope, reduced fraction, 2. So always reduce it, clean it up. That's my slope. Now, in order to do point slope, you need a point and the slope. You have 2 points. Pick one. Doesn't matter which one. Which one do you want? The first one? Okay. Negative 6, positive 1. It does not matter which point you use. So we're going to plug in that y minus 1 equals our slope times x minus a negative 6. Now, if I asked you for the equation written in point slope form, you would have y minus 1 equals 2 times x plus 6. There is your point slope form. But we want to take a minute and we want to solve this for y equals mx plus b. So again, point slope. Simplest point slope form. And then distribute that 2. And then add the 1. And we have gotten y equals 2x plus 13. Now I do want you to think about something. If I asked you to graph a line, you could simply graph it by graphing 2 points and connecting them, right? If I gave you a point and a slope, you would start with that point and then graph rise over run. You could also graph using your y-intercept and then your slope. So we could graph for many things. All right, I know this is above and beyond, but just hear me out on this. Let's say someone else picked the point negative 3, 7. Isn't that the other point? If someone, you don't have to do this, but I just want to show you. If someone picked the other point, you would have y minus 7 equals 2 times x minus a negative 3, so plus 3. This point slope would be accepted. It's different, but it's equivalent. So we might get, you and your neighbor might have a different point slope, but when I distribute that and solve for y, we end up with the same answer. So do you see that it doesn't matter which point I pick? Do you see that we will get that same answer? Okay, so you and a neighbor might have a different point slope, but we would both get the same slope intercept form. Okay, you go ahead and do 4. first thing is I have to think about it. I need a point and a slope. So I'm going to find the slope first. All right, so here we go. If you want to label your little x1, y1, x2, y2, you may. I'm going to go with 8 minus -2. For some people, maybe it helps them to underline so they can focus their brains. And then we would do that -6 minus a -2. Same deal. If you did this first, as long as you're consistent, we'll get the same slope. I'm getting 10 over -4. So my slope reduces to 5 over -2. So you have to have a reduced slope. Okay, now I'm going to write my equation. I'm just going to pick the first point, but you could pick either. And I'm going to plug it in. So I have y minus a -2 equals -5/2. I can move that negative sign out front, times x minus a -2. Okay, so I'm going to clean up my negatives on both places. And I don't have to rewrite it. I'm showing the extra step. But if you were doing this, like I said, in Delta Math or on a test, you have to have the negative signs cleaned up. So there is your point slope. And now we have to take a minute and distribute. Watch your signs. And I end up with a -5 because the 2's cancel. Subtract 2. And do you agree with my y equals -5/2 x minus 7? I agree with me. Okay, good with that? So always need a point and a slope, but you might have to work for the slope. Now we're going to change it up, but very similar idea. Tell me what you know about parallel lines, just in general. They're never going to do what? They're never going to intersect. The symbol for parallel is that double line sort of railroad. Some people do it vertical, some people do it slanted. So if the lines or parallel lines are never intersect, what would you think about the slopes? If I have a slope of 1/2, what? They have to be the same. So the slopes of parallel lines are equal. So sort of two facts about parallel lines. They're never going to intersect and they have the same slope. Now let's talk about perpendicular lines. Perpendicular symbols like an upside down T. Tell me about perpendicular lines. They do intersect. Anything special about it? When lines are perpendicular, what do you know? They meet at a 90-degree angle, right? So they definitely don't have the same slope. Does anybody remember about the slopes of perpendicular lines? They are, I use the term opposite reciprocals. So we need to know that. And I feel like now that I said it, we know it. Maybe. Opposite as in change the sign. If it's positive, make it negative. If it's negative, make it positive. Because they have to go against each other, make that 90-degree angle. And what's reciprocal mean? Flip the fraction. Now, you might see someone use the term negative reciprocal. I don't like that because then people just think it's always negative. You change the sign. A negative be positive. Okay, so how would I know if lines were parallel or perpendicular? That's sort of the directions here. Are these lines parallel or perpendicular? In order to determine that, I'm going to compare the slopes. Now, what form is this line in? See that 10x plus 5y equals 5? That's standard form, and this is, I don't know, just out there, right? Can I find the slope in standard form? No. So I want to compare the slopes by doing y equals what? mx plus b. So whatever I have, I want to get in the form y equals mx plus b because then I can pull the slope. So I can't just look at this. M is paired with x, but only if it's in slope-intercept form. So cross the line, change a sign. We did this the other day. These are like our little equations. I do need you to remember that the 5 and the 10x aren't like terms. So you could write 5 minus 10x, or if you don't like that, you could have it as negative 10x plus 5. It doesn't matter to me how you write it as long as you're getting it correct. And I have to get rid of that 5, and I like to divide each piece by 5. I don't like to make a big fraction. I'm going to divide each piece. So my equation is y equals negative 2x plus 1. What is the slope of my line? -2. Now, let's do the other one. What do you want to do here? I want to leave y where it's at, move the 16, or just move it all around? What would you like? Okay, I'm going to leave y where it's at. I'm going to subtract the 16. So I have it as -x minus 16 equals 2y. So there's y. I just need to divide everything by 2. And when I say everything, I mean each piece, both sides. So I end up with, what's this number in front of the x here? Isn't that a -1? Isn't dividing by 2 the same as multiplying by that 1/2? So I have -1/2 x minus 8 equals y. If that bothers you, rearrange it. Y equals -1/2 x minus 8. Slope is always paired with x, so the slope is -1/2. Okay, what do you notice about these? Are the slopes the same? So they're not parallel, right? Are they opposite reciprocals? They're reciprocals, but are they opposite? If this is a -2, this would have to be a +1/2, right? Okay, so here's the deal. If lines don't have the same slope, they're gonna intersect. If they are opposite reciprocals, then they'd be a special 90-degree intersection called perpendicular. So these are just not parallel. They're not parallel or perpendicular. They are different slopes. Which means intersecting lines. They're going to intersect. We don't know where. We know they're going to intersect, but they're not parallel, but they're also not perpendicular. Okay, perpendiculars are just a special intersecting line. All right, look at the next one. These are both in, that's in standard form, that's in whatever. So let's solve. I'm going to subtract the 8x. I'll put it first. And then I'm going to come in and divide everything by -6. And I get, oh, shouldn't this be a y? Okay. And then I get y equals, oh, I've got to reduce this. +4/3 x. Man, I am all out of whack. Shouldn't this be +42 minus 7? Okay. So you do the next one while I clean myself up. All right, so now that I've cleaned up my mistakes, my slope here is +4/3. And when I list the slope, I don't list the x, it's just the coefficient of x. Okay, over here, I can just jump in and divide each piece by -3. So I end up with y equals -3 plus 4/3 x. And don't get deceived, the slope is not -3, the slope is always paired with x, so m is 4/3. So what do you notice? The lines are parallel. So parallel lines, but you need to back it up. Why are they parallel lines? They have the same slopes. Now, when you're doing work, don't say, oh, I did it in my head, I know they're parallel. Part of the work is to show y equals mx b, pull those slopes. Okay, I want to see what your slope was, because if you made a mathematical mistake, I can at least see what you compared to get that answer. Okay, so we have 2 more. Let's knock these out quick. There's a 0 over here, and that's fine. So when I go to add the 8x, I get 8y equals just negative or positive 8x. Divide by 8, and what do I end up with? Y equals x. Okay, well, what's the slope of that? Isn't it a 1? Isn't that the same as saying 1x plus 0? So I got y equals x. My slope is 1. All right. This guy, we're going to subtract x. Negative y equals negative x plus 4, or 4 minus x. But I do need to get rid of that negative sign. So some people know they're just changing the signs. You're really dividing everything by -1. And I get y equals positive x minus 4. And the slope of this line is also 1. Oh, I should bring this up. If they had the same slope and the same y-intercept, then they'd be the same line, right? So if they have the same slope, they're parallel as long as they have different y-intercepts. So pay attention for that. So these are also parallel lines because they have the same slope. Okay, so they should have different y-intercepts or they are the same line. Okay, let's talk about number 8. That's a little different, isn't it? The equation says x equals 2. Can I solve this for y? Nope. Tell me about this equation, x equals 2. What's undefined? It is a vertical line, and I was told it was undefined, but I don't know what it is. I heard it. The slope is undefined. Okay, so this, yes, this is going to be that vertical line. If you were thinking about a quick sketch of it, it would go through the x-axis at 2. Okay, cuts through the x-axis at 2, and the slope is undefined. Okay, what about y equals 2? It's going to be your horizontal line. What is the slope of that? The slope of a horizontal line is 0. Well, I want you to think about this. If I graph that at y equals 2, what do you see happening with these two lines? I mean, they're definitely not parallel. They are making an intersection, but not just any intersection. You're telling me they are perpendicular. Why are they perpendicular lines? Well, if you think about it, you can consider this opposite reciprocals. The undefined slope is something like 1 over 0. And this slope could be 0 over, and let's say -1. There's that idea of the opposite reciprocal. They are inverses of each other. So they're perpendicular lines. Slopes are, write that down, slopes are opposite reciprocals. Now, technically, any vertical line and any vertical and horizontal line are going to be perpendicular. I just want to get that idea in your head. Okay, we have one more idea building off of that, but we're putting everything together now. So we're going to determine the equation for line that's either parallel or perpendicular to what I'm given, and I'm going to graph it. Okay, so here's the deal. I'm given this line, x plus 3y equals 6. This line is in standard form, so if you wanted to graph it, you could use your x and y intercepts, or you could do y equals mx plus b. We could graph it. But if I want to create a line that's parallel to it, I have to know more information. Any line that's parallel is going to have the same slope, right? But aren't there infinite lines that would be parallel to this? Like I could draw this line, and as long as it has the same slope, it's parallel. This is your anchor point. So let's go ahead and take a minute. Let's graph this. Let's solve it for y. Cross the line, change the sign. Divide everything by 3. And I've got y equals -1/3 x plus 2. Be careful with that. This is your original line. The slope of this line is -1/3. The y-intercept is 2. All right, take a minute and graph it. Put your point on the y-axis at 2. I'm going to go down 1 and then right 3 because I have a negative slope. Down 1 and right 3. I could go up and then left 3. And then sketch in your line. Now that I have that done, I want to find a line parallel to this. And so that's what I was telling you. Any line that has the same slope of -1/3 would be parallel. Like I could draw lines all over this and they would be parallel to it, right? I specifically want the line that is parallel but goes to the point 3, -2. So if you find this point on this graph, +3, -2, couldn't I just get right in here and say, oh, here's my anchor point. I'm going to go down 1 and go right 1, 2, 3. And I can go up 1 and right 3. And you see that I have created a line that is parallel to the line that I have. Now, that is not how we're going to do it. We're going to do it algebraically. But I want you to see that relationship. I know the slope of the line, and if my line is parallel, so my parallel slope, I'm going to use my parallel symbol. Parallel slope would also be -1/3. And I'm going to use this as my anchor point. Do you see that I'm back to the beginning? weren't the first two problems I gave you a point and a slope, and then we plugged it in and we found the equation? So I had to find the slope of the line they gave me. I know any line with the same slope would be parallel. And we graphed it, but you are going to do the algebra. So you can't be like, oh, I graphed it. I'm looking for algebra. So what's the algebra? I'm going to do y minus y1 equals negative 1/3 times x minus x1. There's my point slope. We're going to take a minute and we're going to clean it up and distribute. And if you need to double check your math, go ahead. And then we just need to finish up by subtracting 2. And there is the equation we're looking for. Y equals negative 1/3 x minus 1. This is the line, and it does graph correctly. Put a point at negative 1, down 1, and over 3. So first, you had to find the slope that you were going to use based off of this. And once you knew your slope, you'd say, hey, if it's parallel, I'm going to use the same slope and this anchor point and do the same process. Now, what if I asked you to find a line that was perpendicular to it? What would you have done? So if it was perpendicular, your slope would be a positive 3. So here we go with this. Find the line perpendicular to this that intersects the point at 3, negative 1. I need you to understand that this point is not on this graph. The only reason you're getting this line is so you can find the slope to create your new slope. So first thing I need to do is rewrite this in slope-intercept form so I can find my slope. All right, so go ahead and get that cleaned up. Divide everything and then clean up all the signs and any fractions. That's the equation I got. My slope is positive 3/2. My y-intercept is negative 3. So that's what my graph's going to look like. Rise 3, positive 2 to the right. Rise 3, run 2. You can always reverse it to go negative and a negative, and then sketch in your line. Now, my new line is not supposed to be parallel. It's supposed to be perpendicular. So this is how I help myself. There's my original slope, and then I put my little symbol because I want the perpendicular slope. So what would be perpendicular to 3/2? The opposite reciprocal would be negative 3/2. And my anchor point they gave me was 3, negative 1. So if I just wanted to look at the graph, I would come over here and I'd start at negative 1. Oh, sorry, I just lied. I would start at 3, negative 1, and then I would go down 1, 2, 3, and right 2, or up 1, 2, 3, and left 2. That's why we need the opposite reciprocal. We need it. I feel like I didn't flip. No one wants to yell at me. I didn't flip my fraction. Okay, I fixed my slope. I talked about the opposite reciprocal, and it definitely wasn't perpendicular. I didn't flip it, so I saw the problem. So I'm going to start at my point 3, negative 1, and then I'm going to go down 2, and then right 1, 2, 3, and that looks better. Up 2 and left 1, 2, 3. So what I was talking about is you have to have the positive and negative so they get that 90-degree angle, and you have to flip the fraction using the reciprocal, or you can see it's not quite a 90-degree angle, as I just happened to show you. Okay, you can't just look at this and be like, I'll just write the equation of my line based off of this. We need the algebra, because I'm not going to be asking you to graph these. I'm going to ask you for the algebra. So the algebra is going to be y minus a negative 1 equals my slope of negative 2/3 times x minus the x1. Clean it up and distribute. And then just subtract that 1. And I get y equals negative 2/3 x, and I have plus 1. Now, I'm going to verify that, yeah, I should start at 1 and go down 2 and right 3. And there's my line.